Добрый день, уважаемые коллеги. Мы начнем наше заседание. Наша панельная дискуссия называется «Ядерные технологии на службе медицины будущего». Вы знаете, предваряя нашу беседу, я бы хотел сказать несколько слов. Вот вы знаете, так, первую картинку можно увидеть, что-то она не выходит. Так, будьте добры. Так, мне нужна первая картинка, она не выходит. Ага, очень хорошо. Вы знаете, вот я хотел бы вам сказать несколько слов. Вот 70 лет назад, ну уже больше, как бы в стране, почти 80, начал реализовываться атомный проект. Атомный проект имел одну единственную цель – создать атомное оружие. Больше никакой цели другой не было. Но когда вы решаете стратегическую задачу, вы взрываете цивилизацию на много десятилетий, создавая устойчивую базу для развития. Вот атомный проект, который имел только моноцель, никто не говорил слова инновации, зачем это надо, кому, для чего. Надо было выжить. Вот они бросили бомбу на Хиросиму и Нагасаки, да, и было ясно, что потом они бросят ее на нас. И если у нас не будет атомного оружия, нам конец. И мы его сделали в короткий срок. Но когда вы решаете стратегическую задачу, вы взрываете цивилизацию и на десятки лет определяете ее лицо. Сегодня наша с вами страна является конкурентоспособной в самых высокотехнологичных, наукоемких областях, в тех, где у нас есть либо единичные, либо вообще нет конкурентов. В первую очередь речь идет об атомной отрасли. Но параллельно, когда вы решаете стратегическую задачу, вы параллельно решаете массу задач, которые дают новый облик цивилизации. Вот если мы с вами посмотрим, я не буду вас сейчас утомлять, но просто если вы посмотрите внимательно на эту картинку, например, математическое моделирование и компьютеры, суперкомпьютинг возникли из-за развития атомного проекта. Атомная энергетика возникла как последствие атомного проекта. Термоядерная энергетика, есть развитие атомной, явилась тоже последствием атомного проекта. Сверхпроводимость, которая сегодня уже новая электрогенерация, новое электродвижение, принципиально новые вещи, тоже родилась в поддержку обеспечения термоядерного синтеза. Атомные ледоколы, которыми обладает наша с вами страна, тоже вышли отсюда. Это есть единственная, мы единственная страна в мире, кстати, которая имеет атомные ледоколы и двигается полным ходом. Как атомная энергетика в космосе, атомные подводные лодки, другие корабли, кроме ледоколов. То есть вот весь облик цивилизации, наше лицо, которое абсолютно очевидно, узнаваемое и практически не конкурентно, как в атомном ледокольном флоте, я легко перенесу в сторону ядерной медицины. Ведь для того, чтобы создать атомную бомбу, вам надо было сделать всего лишь две вещи. Первое. Вам надо было, у вас природный уран-238 не делится, из него нельзя было сделать бомбу, построить реактор. Там всего лишь десятая доля процента 235-го урана, который делится. Значит, вам надо было сделать две вещи. Либо создать систему обогащения природного урана, так, чтобы стало делящегося столько, чтобы он мог там взорваться или стать топливом для атомной станции. Либо наработать новые элементы, облучая уран природный, получить, например, несуществующий в природе элемент, такие как плутоний, из которого была сделана наша первая бомба. Но для этого вам надо было создавать систему обогащения изотопов раз, вообще изотопную промышленность, радиохимию, сложнейшее дело. И второе, что было важно, вам важно было создать уникальные мегаустановки, речь идет об ускорителях и нейтронных реакторах, в которых через облучение элементы трансформируются в другие. Тоже изотопы, не изотопы и так далее. То есть, короче говоря, атомный проект состоялся, потому что страны, а это Соединенные Штаты и Советский Союз, наша с вами страна тогда так называлась, решили две проблемы. Создали систему обогащения природного урана, раз, и систему работы с изотопами, их наработку, использование и так далее. И второе, создали мегаустановки, в которых тоже могли нарабатываться новые элементы. И это есть база. Во-первых, я хочу обратить внимание, тогда были созданы технологии, например, наша технология обогащения, которую создал академик Кикоин в нашем институте, уже более 70 лет является лучшей в мире. Мы являемся крупнейшими поставщиками обогащенного топлива на мировой рынок. Дальше, мегаустановки, которые начали строить, их создавали только мы, американцы. Это был атрибут атомного проекта. А сегодня мегаустановки – это нейтронные реакторы, это ускорители, это синхротроны, генерирующие мощное рентгеновское излучение, рентгеновские лазеры, циклотроны и так далее. Это приборы, которые составляют основу научного прорыва, формирования, создания новых лекарств. Например, у нас на синхротронном источнике, единственном на постсоветском пространстве, специализированном в Крыльчатском институте, создаются новые лекарства на атомарном уровне. Сегодня нет лекарства, которое бы создавалось без использования синхротронного излучения. Нет радиофармпрепаратов, которым предшествовала сложная научная работа. Я это говорю к тому, что вот эти установки создавались фактически нами и американцами. И сегодня любая страна, которая пытается сказать, что она встала на путь высокотехнологичного развития, она старается завести у себя подобного рода мегаустановку. Это есть показатель, что страна может эксплуатировать такой сложный прибор. А страны, которые разрабатывают эти установки, умеют их придумывать, делать и строить, это, так сказать, элитный клуб, единичные страны, в которых наша страна, Россия, занимает ведущее место. Я, более того, вам приведу простой пример. Например, в основные вещи, которые лежат в основе любого ускорителя, того же ЦЕРНа, это автофазировка, придуманная академиком Вексером, и встречные пучки, придуманные академиком Буткером. То есть основные принципы, которые лежат в основе, тоже придуманы нами. Вот сегодня запущен самый мощный и самый дорогой проект Германии «Лазер на свободных электронах». Это российская идея, наши технологии в существенной мере и наши деньги. Мы туда вложили 500 миллиарда евро. Так вот, я это сказал для чего? Того, что мы являемся одной из немногих великих стран, которые стояли у истоков того, что их ставило инфраструктурную основу ядерной медицины. Более того, одни из первых применений протонных пучков, вообще пучков частиц для лечения, для изучения, были начаты у нас. Я более того вам скажу, во времена еще в начале 40-х годов, 43-й, 44-й год, в Курчатском институте, а после 46-го на полигоне в Семипалатинске были созданы подразделения, которые занимались изучением влияния облучения на живое. На живое. Это было еще в предшествии первого атомного взрыва, который мы реализовали 29 августа 1949 года. Так вот, вопрос, поэтому генетика, самая мощная генетическая лаборатория в стране, и одна из знаковых мест в мире, одно было генетическая лаборатория Курчатского института. И сегодня Курчатский институт головной по генетической программе, потому что институт госнеогенетика, выросший из Курчатской генетической лаборатории, сегодня часть нашего института и составляет базу для этого продвижения. Теперь, говоря об этих установках, значит, страны, которые умеют их строить, я уже сказал, входят в элитный клуб. Мы всегда были впереди. Я хочу вам напомнить, я к этому подойду потом, что мы всегда были пионерами в массе направлений по созданию мегаустановок. А ядерная медицина – это изотопы, фармпрепараты на их основе и новые мегаустановки. И вот сейчас мы, когда после распада Советского Союза мы вышли наружу...
When after the breakup of the Soviet Union we came out and one of the iconic high-tech scientific potential, if I may say so, went out in the open market. We effectively were picked up when the country didn't have any money in the 90s, and we were able to launch all of the main projects in Europe. That is about the CERN and the thermonuclear reactor synchrotron center. So we made it possible for these projects to take off. We acted as their donors and initiators, and today we have come back, having become an inextricable part of the European landscape, having invested into the European project more than 2 billion euros. And so these installations, do belong to the Russian Federation through the Kurchatov Institute and have come back into Russian territory in accordance with the presidential decree and the government-supported program. We are, as of this year, launching a very powerful infrastructure program to produce world-class installations in units. Within the next 5 to 8 years, we will have a research infrastructure that nobody else in the world can have. The PIC reactor at our site in Gatchina, then it will be the construction of the new synchrotrons in the Far East in Siberia, the creation of a new machine which doesn't have any facilities at the Protvino site, not far from Moscow, and a separate site dedicated to the development of the nuclear medicine, healthcare. We're talking about setting up proton accelerators and the accelerators for ion therapy. So I simply wanted to draw your attention that this is a very first important circumstance, and the first application of the proton therapy basically started simultaneously in Russia and in America, but we were one of the first ones. Moreover, despite the fact that recently we have a few failures that many are talking about, we retain a much greater number of patients who have gone through this treatment up till now. And it all was developing at the Kurchatov site in the Gatchina and in its Moscow location. Up till now, we're able to retain the number of patients who went through this treatment, and the biggest number of them in the world. Another thing that I wanted to say, that the nuclear healthcare, nuclear medicine is not just a medicine. I'm tired of saying it yet over and over again, but I would like to say it again. This is nuclear technology, which, in the end of it, is something that a physician is using who doesn't have to know the details of this technology, the way it operates. But the situation is such that if we want, in a mass consumer way, to apply these technologies safely, we must base them upon the nuclear centers who have the culture and the whole infrastructure to be able to handle radioactive substances and the radioactively hazardous environment. A doctor is the user, and the doctor cannot select such an installation, cannot design it. He must participate with the physicists, formulating the targets and the tasks that this or that accelerating technology is going to be fitting. So successful development is only possible when we will have a very clear understanding that this or that nuclear technology is being used by the physicians with the help of physicists. We need to prepare a special class of physicists who will be understanding the healthcare objectives, as well as the medics who will have the fundamentals of the physics and science. So that's what we're going to talk about. I would like to give the floor to Sergei Anatolievich Tsib. First Deputy Minister of Industry and Trade, but I would like to say that Sergei Anatolievich, it's not that I made a mistake mispronouncing his name. Apart from him being an outstanding person who is so knowledgeable, he was born into the family of one of our biggest academicians, Academician Tsib, who effectively stood at the roots of the development of the nuclear medicine in this country in a broader sense of it. I mean, from the healthcare point of view, together with Academician Granov in St. Petersburg. So at the Obninsk site, they were doing this work. So Sergei Anatolievich was being raised in the environment of how to enhance the nuclear medicine and healthcare regionally. Yes, thank you very much, Mikhail Antonovich. Good afternoon, dear colleagues. In the first place, a great many thanks for the good memory of my father. Mikhail Valentinovich, I believe, in a very correct way, led our discussion to the development of the nuclear technologies in healthcare, taking into account an enormous experience as well as the foundation which was laid down during the Soviet times in the development of the nuclear physics, and henceforth an emergence in the Soviet Union back in the 1960s and 50s and 70s of the biggest radiology centers who, on the basis of the then created infrastructure, because infrastructure is a whole separate story, it does require a whole separate panel to talk about it. Why? Because this is very capital-intensive infrastructure in as far as investments are concerned, and very high-tech in as far as creating conditions are concerned in order for such technologies to be applied in healthcare, considering the safety as well as the efficacy and the availability of such technologies to the citizens of the then Soviet Union and currently the Russian ones. So, of course, these prerequisites do give us the reason, and we started really getting engaged in it when we were trying to endorse the strategic documents in the Ministry for the development of the nuclear pharmaceutical industry. So we have the full grounds to say that we've been able to do something with the past 7 to 10 years. However, there are prerequisites for us to develop this high-tech area in Russia further, taking into account the fact that all of the basic components that are required to introduce such technologies in the Russian healthcare, one way or another, do exist, and it is a very obvious thing that there is a separate HR issue considering the interdisciplinary nature of radiology and the nuclear medicine. That includes radiochemists and radiobiologists and radiophysicists. So there's a great number of people who, from adjacent specialties, participate in this. So the whole issue itself, that the way it was phrased, nuclear medicine and nuclear technology, is a very sensitive segment where towards the end of it you have the physicians, but in the process itself there is a great number of experts that are getting involved who, in the technology sense of it, are preparing the finishing line for the physicians to cross. There are also issues of logistics which require a very elaborate debate and various decision-making because, there are, short life and long life isotopes, and there is a development of an infrastructure in terms of their application, which also requires respective approaches to be developed in terms of certain new systemic logistical solutions which would enable to quickly and efficiently to deliver any of such products to any destination in Russia in order to provide patients with the necessary health care. There is also a financial set of issues which I feel is worth discussing, bearing in mind the fact that we've got quite a number of resources which are being allocated to it, both from the federal and the regional budgets. And in view of some very serious pricing processes for similar technologies, as part of the healthcare aid, everything which is related to tariffs, as a subject, I feel does require additional thinking, additional decision-making, so that investors would be interested to invest money into it for the development of the medical and healthcare infrastructure on the basis of radiology. And we see that there are companies like that that have appeared in Russia and actively invest into it. So the issue of tariff development and connecting it to the program of government guarantees so as to be able to bring these methods into all of the guidances and guidelines for the healthcare as a service is a very important part, because one has to understand what will be the way through which all the investments are going to be recouped. So we do see, in other words, that this is the segment where one notices an active presence of the private business, and this private business is not only participating in providing aid, but also in establishing production capacities, be it for the radiopharma products or the medical devices which are being used in this sector. Of course, there are major government players in this area, because the Kurchatov Institute has been in it for a long time, actively invests and actively promotes itself as one of the major centers which not only is developing and designing and creating various opportunities to produce radiopharma products. And we, as the Minister of Industry Trade, amongst others, do collaborate very seriously with the Kurchatov Center, with the strontium and rubidium generator that we are working on as a joint project. Many other projects that we are supporting as well. The Kurchatov Center in the area of healthcare is playing a very significant role in providing healthcare aid, amongst other things, to the Russian citizens. There is also the Rosatom, the Russian nuclear agency, and other government institutions, which today are very active in designing, in developing and producing radiopharmaceutical products, because we have the Federal Radiobiological Agency, and it has various major government institutions underneath it as an umbrella who are also involved in this work. So it seems to me that it's very important for us to do the correct prioritization. Why? Because on the one hand, we must base ourselves upon the trends which emerge in the world. By way of an example, I can give you the oncological radiology, oncological treatment. Currently, it enters into the market, and the oncological products with the radioisotopes, which basically are part of the individualized healthcare. The first such product, lutetium-177 isotope. We see how work is being done with actinium-2025 and many other isotopes, which longer term, definitely as far as the global market is concerned, are going to be very actively applied in as far as the targeted treatment is concerned that they can offer, bearing in mind this narrow impact, very effective impact upon various tumors. Therefore, all of this must be borne in mind. And we, as the Ministry of Industry and Trade, let me say a few words what we do in supporting the production of radiopharma products and medical devices. As part of the government programs, we have supported many, many projects, more than 35, in as far as the preclinical and clinical trials involving the radiopharmacological products. The manufacturing site organizations which supported the designing of the medical devices. There are certain things that we already see in the Russian market, gamma therapeutical machines we already have, and the new types of units in the area of medical diagnostics, mammographs. Just imagine, we have companies which produce very serious healthcare technologies. We organize the assembly lines. Another project like that is going to be commissioned in the city of Dubna. With the radio treatment factory. This is the subsidiary of the R Pharma company, the assembly of the linear accelerators, the innovative solutions that they have. So we pursue the same kind of plans within the Russian Nuclear Agency cooperation, jointly with other international players, and as far as the localization of certain types of medical devices is concerned, I am aware that the Kurchatov Institute, together with the Obninsk Medical Center, currently is looking into establishing an ion therapy center. In our time, we funded, I believe, a very interesting project, having set up the proton treatment center in Obninsk on the basis of a modern installation that academician Balakin produced. This is another area whereby we may say we will see the development of not a portable but small-sized units. Not compact-sized ones, definitely, for the proton therapy, which is, it seems to me, an important issue that is worth being debated together with exports. For example, we have Dimitrovgrad as a location. We have other major initiatives in as far as other projects are being implemented for the development of the proton therapy. Therefore, here one must make certain decisions in terms of which journey to follow. Maybe establish such proton therapy centers in the oncological institutions in different regions or in any other locations in Russia. So this is something that I would say requires attention on the part of the healthcare experts, as well as the experts who are quite understanding what is radiology, what is nuclear medicine, what logistics it requires. So I would say this is one of the items that definitely could be discussed. We are actively, amongst other things, currently participating in implementing the plans for the development of the nuclear medicine that had been previously endorsed by the government. And in as far as this is concerned, I've always been supportive of one simple thing. Bearing in mind the fact that major private investments have started coming into the sector, one really have to focus upon the true priorities so as to participate in the development of the radiopharma products to support the projects that the major centers are currently working on to set up the infrastructure for the production of such products. And now taking into account the development of the public-private partnership and bringing in private investments into this industry, I believe we must create the maximum possible flexibility in order to raise private investments to finance the capital expenditures. I think that the government shouldn't be investing money into building, I don't know, the foundations, the equipment. This is something that private investors can do, and the government here, by bringing in resources into expanding the tariff system and providing great opportunities for the nuclear-based medicine, just make it possible for the private investments to flow into it. And we, as the Ministry of Industry and Trade, will continue to be actively supporting it because I see it as one of the most promising high-tech areas. And as far as the healthcare aid is concerned, not only in this country but the world over. Unfortunately, our market here is not as big, I mean, for such technologies to develop into certain end-user demand, because about 40% of the global market is United States, 20% Europe, while the remainder is split in between the rest of the countries. So the market for the application of such technologies, even for the radiopharmaceutical product, is not as significant, so that in certain segments to be the main driver behind the growth. What I mean to say by it is that we need to use our competitive advantages, something that I mentioned at the very beginning, because we've got a very powerful isotope base, and this kind of a competitive advantage we may use in order to create a very powerful manufacturing complex for the nuclear pharmaceutical product and exporting. So this is our task as the ministry in some immediate future as part of the national projects, international cooperation and export, to try and actually develop this particular sector together with everybody interested. Sergei Anatolievich, I think that whenever you talk about our local market, we need to apply our competencies, and this is something that we will talk about additionally and create the national basis. It's a different thing that we need to create it in cooperation with the leading global companies which come from the places where this has become evident, like in proton therapy, or establish our own like the ion-based therapy. But I would say that speaking about the market, for example, there is China and all of the former Soviet Union republics. Effectively, this is a very huge market where the demand for the nuclear-based medicine is very strong, and using the new Eurasian Economic Union and our growing cooperation with China, and certain tangible steps have already been taken there. So this is the kind of a big market that we are quite capable of developing. So there is a lot of future in it. Now, after listening to Mr. Tsip, who has described the general picture and the government vision of it, which is very positive, I would now ask Mikhail Piratov, the academician, the director of the Neurology Institute, to share with us his clinical view on this. Thank you, Mikhail Valentinovich. A little bit over 35 years has gone by, almost exactly 30 years since the Nobel Prize was being issued for the computer tomograph and magnetic resonance tomograph. Today we're talking about magnetic resonance tomograph, MRI technology, and these two units have created a permanent revolution in healthcare. What we received in being able to diagnose different illnesses can be compared, I don't know, maybe with the discovery of a new planet. Because, as it turned out, many of our ideas about various maladies that human body suffers from are totally different from what exactly was happening. And in the course of all of these 30 years, the MRI technology continued to be the driver behind the development of the diagnostics. But wherever you have diagnostics, whereas, for example, here you have a lot of physicians, and we understand that where you have proper diagnostics, you can achieve an effective treatment of various conditions. And we were able to peek inside many of human body organs, not only understand their structure, but also various changes which occur in different pathologies. We were able to learn how blood is circulating through these organs. We were able to study a lot, practically all of the human body, and ultimately have come to the most important organ, which is the supreme creation of the Lord on this planet, which is the human brain with its 86 billion of neurons. I don't know if one is to ask a question, who are we? What are we? We are what our brain is. And this colossal interest, which is demonstrated towards neurosciences, comes from us becoming very well aware that without being able to understand this very complex structure, we won't be able to go any further, even despite the artificial intelligence, Mikhail Valentinovich. I really hate to... Yes, it is a very interesting. It's a separate discussion, really, because views differ here. I do say that it may lead to the human civilization fading away completely, but let's not talk about it right now. So, what I would like to say, having begun studying the human brain, we started discovering very unusual things. We started getting an understanding not only about how various pathologies develop inside the brain and generally what is happening with its various parts, but this rationale of the development, first of all, on the side of the physician, because those were physicians, it so happened, who went into the magnetic resounding technology, and this particular technology, together with the emission positron technology, was able to expose many things which otherwise would have remained completely unknown in our studying the nervous and neurous system. So after we learned about various pathological changes in the brain, quite naturally, many doctors started thinking about taking this experience and going with it somewhere further. And so the logic of the development of specifically what we are doing in the Neurology Research Center pushed us towards starting to learn the physiology of a healthy brain. And here, with the help of the MRI and CT, which to a certain extent, with regard to the points that I'm going to talk about, substitutes the positron tomography, which calls for the need to install cyclotron and the need of very rigid logistical shifts because of the short life isotopes. So with the help of such technologies as the functional magnetic resonance technology, it was possible to start to learn other conditions. For example, what is memory? Memory is one of the core properties of the brain. Memory is almost everything. This is learning, education, and training in anything. And so with the help of the MRI CT, we were able to achieve totally new opportunities in as far as our ability to understand what our memory can do with the help of other devices which augment the magnetic resonance. And I'm talking here about different methods of uninvasive stimulation of the brain. For example, only after one session these days of such an impact, we're able to enhance the amount of brain's memory by 20%. It's a different matter in terms of how long this particular state continues to remain, and we're working on it as a project right now. Together with Mikhail Valentinovich, for quite some time we've been having a conversation about it, and specifically about selecting people, screening people from specific occupations in order to perform the functions related to the management of transportation flows. And these are aviation controllers and controllers of major transportation hubs and other big structures where there is a requirement for such a precision of response and concentration. And so with the help of the functional tomography, magnetic resonance tomography, you can assess whether this or that candidate is suitable to perform this or that work. And maybe just to agitate us a little bit more, I can give you an example. Just imagine there are two people who were put inside the MRI, and they were asked to multiply, let's say, 89 by 63. Every time they perform these calculations, both of them in their minds, and respectively, the people who were assessing these results, they have taken a look at them, and it turned out that one person, the center of agitation, which was assessed with the help of the functional magnetic resonance tomography, has it this size, while the other is this size in diameter. So the question is, who should be chosen? What do you think? Well, I suppose the one should be chosen who has it in a smaller size. Why? Because this person requires less effort in order to perform a very complex calculation of the between the two-digit figures. Maybe he's a nutter, and that is why he doesn't require so much brain to do it. Maybe, yeah, maybe you're quite right. So, moreover, it is very interesting to consider other issues related to detectors, not the lie detectors. No, I don't want to describe them that way. So right now, a selection of candidates into certain structures, or the task to understand whether a person is telling you the truth or lies, is based upon the heart rate, upon certain respiratory expressions on the palm of the hand. But those adepts of various spiritual practices have long ago have learned to control their bodies, and so their heart rate doesn't change, and the frequency of their breathing remains very stable during the most provocative questions and trials. But so far, nobody has mastered the ability to regulate the circulation of blood in certain parts of the brain. So the magnetic resonance technology specifically is based upon the greater inflow of blood to certain parts of the brain. So whenever you interview a candidate, for example, who gives you reasons to be doubtful about something, it is very easy, despite the fact that he is keeping up his posture, is in control of all of his perspirations, it is very easy to detect the extent to which this or that provocative question starts worrying him, and how honest his answers are. So, I'm telling you this as examples. But going back to the nuclear medicine, I really want to say that this is an absolute revolution, because nowadays, if we talk not only about the magnetic resonance, but about the positron emission tomography, you won't believe it, but just within 30-40 years, one can predict the development of the Parkinson's disease and the Alzheimer's disease right now with the help of the positron emission tomography. These research projects are currently being done in the world, and consequently undertake various prevention measures. So this is the kind of revolution, and I'm always repeating this word, which turned MRI technology as a phenomenon in healthcare. It continues still, and it seems to us that we are far from being able to exhaust all of the opportunities that this phenomenon presents us with in healthcare, in neurophysiology, in an ordinary human life, in selecting people to various important and complex functions. So the future of this particular method in healthcare and in our society is enormous. And so let me finish on that note. Thank you very much, Mikhail Alexandrovich. So, yes, give a big hand to him. Yes, it was a very good speech. So I really would like to say that it is true that the nuclear healthcare methodologies, in the broader sense of it, in the positron emission with an application of the radiopharmacological product and magnetic resonance, which has a different nature, do open unique opportunities, the one that you have just described. But I would also like to say that at the Kurchatov Institute, you're also aware of it, Mikhail Alexandrovich, quite well. Several years ago, we have established a special laboratory, and we have created and patented the polygraph compatible with MRI. This was a complex thing to do, but we were the first ones to do it several years ago, where MRI technology, we were talking about it, is whether you can basically choose yogis who can regulate their breathing, but if you put him into MRI device together with a polygraph, that would be a much more complex thing. So we have come up with such a device, we have patented it, and so this is another revolution in this pre-screening. So this is a very important thing. So, you know, we do understand that we usually know quite well that radiopharma products and the positron emission treatment as a new diagnostic methods very broadly used right now, usually is being used in oncology in a routine way, simply because we have slightly delayed our movement in this. That is the way we see it, but effectively neurology is really playing a very active part in it. And what's important is that the key market in the United States is also linked to the cardio research. So I would like Professor Mishkevishvili to say a few words about it. Yes, could we have a microphone? Here's a microphone, it's behind you. Thank you very much. This is a very interesting topic because we, the cardiologists, and I'm the cardiologist, are much more primitive people compared to neurologists. We're not working on memories. Should I keep silent or not? What's happiness? The happiness is a good health and bad memory. It's arguable, of course, but I'm sorry if I offended you. Mikhail Alexandrovich, you started by saying that whatever we are discussing right now is the consequence of the nuclear project. The nuclear project was launched in order for us not to die quickly and painlessly. But unfortunately, having avoided this kind of death, many people take a lot of time to die. But this is not related to the nuclear project at all. No, of course. No. Let's make a caveat. Yes, it's not related to the nuclear project. It is basically explained by the fact that we have started living longer, and more than half of the people in this country die from the cardiovascular diseases. You know, people are saying that everybody is afraid to die from cancer, but they die from the heart failure, the mortality from which exceeds... Oh, what? No, that includes itself. So, you should have an argument separately. No, I cannot argue with our neurologists. No, a little bit of statistics, if I may. Yesterday, the President, in his address, was talking about the demographic problem that we're facing, that we should increase the birth rate and that the Russian population should grow. I think that we should definitely increase birth rates, but at the same time we should save the lives of those who are already alive. We are all. The death from cardiovascular diseases in Russia amongst under 65 young people, 13% greater than in France, 13 times amongst men, and 16 times greater amongst women. We have a national project, healthcare, according to which by 2024 we ought to reduce mortality down to 450 cases per 100,000 people. In America, last time it was in 1973, this kind of mortality rate. We are facing a very serious problem that we need to resolve. And myself, as cardiology, it doesn't matter to me how we're going to reduce this mortality, using nuclear technologies or MRI or pills, but why I think what I'm saying is important, because I do see the way nuclear technology would enable me, as a physician, to diagnose people faster, sooner, and this way help people sooner to avoid death, because diseases which we are calling today, including insults and heart failures and cerebral palsies and so on and so forth. So speaking about the nuclear technology in cardiology, indeed, 60% of all of the research in the world done is being used in the area of cardiovascular diseases. We are certainly not using nuclear technologies for treatment. Not yet, although the same proton accelerators that currently are trying to be used when treating certain arrhythmics. When in the heart muscle you burn a little bit something, and yes, simply, and so people are able to pass through this arrhythmic conditions. Even such technologies already come into cardiology. What's the problem with nuclear technologies in this country? Because the nuclear bomb, and whenever people hear the word nuclear, they having fear. Basically, everything we know in cardiology about heart was received through the methods of nuclear medicine, nuclear technology. Finish, please finish. This is the metabolic conditions and many other things. So whatever we do today, basically, it comes from what has been received back in the 1940s and 50s, including in many ways in this country. But something that we started forgetting. We started forgetting about it. On the other hand, nuclear technologies, they use ionized irradiation, and many are afraid of it. So here again, nuclear technology, radiation, cancer, Chernobyl, Hiroshima, and I can give you a very simple example: positron emission tomography. Just to simplify it, I will translate it into the number of radio screenings of breast, because usually people used to, we heard not more than 2 times a year. So, PT with a full irradiation, about 700 screenings of the breast. Computer tomography, CT, approximately 1,200. Coronography, about 2,000 screenings of the breast. So, nuclear medicine, in terms of the ionized radiation, is much safer, although that might sound strange, compared to many other methodologies, with the exception of the magnetic resonance technology, which doesn't use the ionized radiation. And that is why this is the kind of method which gives us a unique diagnostic result. Very simple, very cheap, very straightforward. Particularly, you hold about the strontium rubidium generator. You don't have to have a cyclotron somewhere near. This could be a generation kind of a method, which I believe in many ways would enable us to improve the situation with the CVS diseases in this country. The European statistical data from September in Europe, they said that 2/3 of deaths from cardiovascular diseases in Europe could have been prevented if we were able to use about what we already know right now. And I believe that in Russia that wouldn't have been about 2/3, but about many more. And we need to actually develop nuclear medicine. We need to train our people. I'm reading the course of the nuclear physics in the Moscow Medical University, and that is why I needed to start learning about the physics in the nuclear science. And so I do believe that the physicians should be aware of it in order to be able to effectively apply it in their work, on the one hand. And on the other hand, we need to develop new technologies. For example, the classic isotope, which is thallium-201, where previously we were basically, it has half life of 7 days. So people were working around getting this source of radiation and irradiating all the people about. We have now thallium-89 with 7 hours of half-life. This is unsurpassed diagnostic value and extremely safe. Met 64 and 67 new isotopes, and so I believe that this cooperation between healthcare and nuclear physics, which unfortunately for many years were apart from each other, would enable us to improve the health of our people and reduce mortality, which for me as a cardiologist is of principal importance. Thank you very much. Thank you. Lev Baranov, who represents recently established a new healthcare company, Nanomek, and we should listen what business is thinking about such topics. Yes, sir, thank you very much. Thank you very much, dear colleagues. As you put it, indeed, we are the final link of this whole chain of nuclear medicine, ourselves and the consumers, because a physician needs to diagnose and start treatment, while a patient needs to be cured as soon and as effectively as possible. So let me begin with a few figures which in healthcare are extremely important and do define certain trends that we can see. For example, average throughout the world, from the point in time when a diagnosis is being issued until the start of the treatment, it takes about 80 to 120 days. So this is the average global data that we see. Now, the second point is that every week after the diagnosis issued increases mortality by 5%. So you can imagine how strongly the this negative outcome increases from the start of the diagnostics to the start of the treatment. So from the point of view of a doctor, that is a much more serious task, because if you take a look at the prostate cancer separately from others, there are more than 27 methods of affecting the prostate. But the ways of treating cancer in prostate gland, there are more than 40 different types of it. So you can imagine how much a doctor should know in terms of combinations of the age of a patient, its clinical history, and various other pathologies and conditions in order to correctly prescribe the treatment for such a patient. So currently nuclear medicine indeed provides us with a certain new opportunity in order to be able to advance ourselves, to undertake a new qualitative leap in treating patients in the first place, thanks to the new diagnostics and specific treatment which ensues from it. Yes, a year ago, Sogars Insurance Company, it has set up the company Omega in order for this company to be able extremely quickly and effectively promote into the market this new product, exactly the new trends that our previous speakers referred to, and to cure patients. And here there are two basic areas, which is the clinical institution that we are already building and which is expected to be commissioned in the beginning of the 21st, or in the end of the 21st and the beginning of 2022, and to try and change the paradigm as much as we can in the minds of the physicians in order for them to start thinking anew about the new technologies that are available to them, which enable them to more effectively treat the subjects. Now, speaking about our clinical center, this is not a hospital, this is a new ecosystem for patients. This is the kind of a clinical institutions where, apart from the neonatal issues, one can resolve all kinds of issues related to rehabilitation of any severity, of any age. So this is kind of a clinical centers which will really achieve the level of being a peer with the world-leading centers that we are familiar with. Indeed, the nuclear medicine in our clinical center constitutes a whole separate area whereby you will have a fully closed cycle of nuclear medicine, and specifically the closed cycle to treat oncological patients. And what's of a principal importance is that in 2022 we will take out into the market the very same radiopharmacological products on the basis of strontium and rubidium, on the basis of actinium, and on the basis of iodine, which would make it possible to turn the diagnostic process into a more individualized one, more efficient, because already now we must be talking not only about diagnostics, but we must be talking about theranostics, which is the system which enables not only to diagnose, but immediately start treating oncological diseases with the help of the radiopharmacological treatment, which are currently being fused. And lutetium, that has been previously mentioned, is one of the most potential kind of products there are. So speaking about the second part of the work of this company, again, in the minds of the doctors, it is very important to change this paradigm, and by this I mean that the phthoric glucose that is currently being used, this is already the matter of the past. Already now you must raise the awareness amongst the physicians about individualized approaches, not only to treatment of the oncological and cardiological and neurological diseases, any diseases, because the amount of knowledge that we have already in genetics, which is currently growing with every day, the amount of knowledge in nuclear medicine, which is also like an avalanche, is growing every day, and the current day physician at this point in time, there are already new therapies and new treatments of traditional similar diseases. And so a doctor today must think about the future and change an approach to the diagnostics and the treatment of various conditions. So this is a big challenge of sorts, definitely, because we all together and all of our colleagues, we're doing new things. We are developing new approaches. We are implementing new treatment regimens. And already now, There is a whole layer of patients whose tumors are no longer sensitive to the proton treatment. Just think about this. Once again, proton treatment came about not long ago in the world as specifically, a routine everyday run-of-the-mill kind of a process to treat patients. But already now there are tumors which are not sensitive to proton treatment, and only thanks to the ion treatment they can be killed. And so the whole world right now is saying that only in the combination between the proton and ion treatments you may achieve the most effective way of treating such a disease. Let me repeat it. Within this ecosystem, within this clinical center that we are developing, there will be all kinds of photon, proton, and ion treatment methods in order to be able to, as effectively as possible, to treat patients. And let me repeat what Mikhail Valentinovich previously stated. Yes, we are consumers, and so we need to take a patient to diagnose him and to cure him. Now, the rest of it, how the products are being fused and synthesized, how ion treatment is working, what's the technology underneath the proton treatment, definitely this is a very important piece of knowledge for the whole number of different skills which are required in order to make sure that this equipment works. But in the end of the day, let's say, thanks to a modern information system, a doctor is supposed to create a certain matrix of treatment and create the most efficacious regimen so as to treat a patient and do it within the shortest possible period of time. So we need to have new expertise, new knowledge, and our company, together with the Kurchatov Institute, together with the BA company, we, through basically about maximum 2.5 years, will offer to the market this very same kind of a product by way of new radiopharmacological products, by way of a new approach to a comprehensive treatment of patients in the area of nuclear medicine. I'm not talking about oncology, because indeed oncology is just a part of basically the number of patients which can be treated and cured with the help of the nuclear medicine methodologies. And in conclusion, the only thing that I wanted to say was that right now, the nuclear medicine is the very powerful conglomeration of knowledge, information technologies, physics, healthcare, which brings about new disciplines, new specialties, new approaches. And certainly we understand that we all put together need to undertake a certain qualitative leap in training these people, in making sure that they are available so that the effect from the application of the nuclear medicines and radiation treatment currently, for the benefit of the people in this world. Thank you. Thank you very much. You see, big corporates such as Sogas Insurance Company invest substantial funds into creating healthcare infrastructure and creating it at the forefront of the modern science. And we heard ABA Company mentioned, and I would like to ask the director of ABA Company, Professor Jongen, Yves Jongen, to say a few words. But before you switch on the microphone, let me say one thing. ABA, a well-known company in the market, practically 30% of proton accelerators have been produced and delivered turnkey by this company. This is an extremely important area, well proven, as once Ladislav Ladislavich mentioned it correctly. This is a bit of a run-of-the-mill thing, because we were developing the application technologies for the proton therapy in the Soviet Union, and we used to say that we had two sites at the Gradovskaya clinic site and in our site in the Gatchina, the Botkins Clinical Hospital, and in Moscow as well. But nevertheless, in the final shape and form, the kind of a commercial product which was created and marketed by this Belgian company. So this is a very good experience, which when having an absolute base, we must take into account in order to undertake future steps. Please.
Ladies, gentlemen, distinguished guests, being in front of this audience is certainly for me an honor and a pleasure. And I would like to thank the organizer and especially Professor Kowalczuk to have invited me here. And I would say, speaking about nuclear medicine in Russia, especially moving, because Russia has really been at the forefront, at the invention of many of the development in nuclear medicine, and the Kurchatov Institute that you lead was certainly a founding stone of this part of medicine. A word of apologies. Before the meeting, I asked who will be in the audience, and they told me it will be a mix. There will be economists, there will be policymakers, and there will be specialists of nuclear medicine. I put myself at the level of the economist and policymaker, and I apologize to my colleagues in nuclear medicine. You probably know what I am about to say. My subject of today will be radiotheranostics, the combination of diagnostic and therapy using radioisotope, which I believe is really the future of nuclear medicine. And if I start with diagnostic, you are all aware that it's possible to attach chemically a radioactive atom, a radioisotope, to a molecule of medical interest to inject this radioactive pharmaceutical product, you speak about the radiopharmaceutical in that case, into a patient, and then follow the metabolism of this labeled drug with an appropriate camera. The camera can look at single photons emitted by the radioisotope. One will speak about the gamma camera if it takes a two-dimensional image, or a single photon emission tomography, or SPECT, if the imager is rotated around the patient, and then you build a three-dimensional image. Another kind of camera, which is much more sensitive, will detect the radiation emitted by the annihilation of positrons, which are positive electrons emitted by some radioisotope, and then you will speak about positron emission tomography, or PET camera. Medical diagnostic using SPECT and PET is a major tool today in medicine, and is used, as mentioned, in cardiology, in neurology, but probably most importantly in oncology. You can, as an example, inject a patient with a sugar that you have labeled with a positron-emitting radioisotope, the fluorine 18, and this pharmaceutical is called fluorodesoxyglucose, or FDG. If you inject a patient with FDG and do a scan, that allows the oncologist to know if the cancer is still limited to the primary tumor, or if it has spread in multiple metastases in the patient of the body. Knowing this is of capital importance to select the appropriate treatment. Nuclear medicine is very developed worldwide, and especially in Russia. I would say, to give you some short number, the world market for radiopharmaceuticals is around $8 billion, and the part of Russia in the world market is around 5%. I just explained that short-lived radioisotopes are extensively used for medical diagnostic, but obviously radioisotope can also put to therapeutic use if, and only if, you can safely bring the radioisotope at the location in the body where you want to apply a strong dose of radiation. Probably the simplest illustration of radiotherapeutics is the use of radioactive iodine for the treatment of a cancer of the thyroid gland. Why? Because the human metabolism is such that all iodine absorbed in your body, for instance in your food, will be transported in your thyroid gland in a short time. So if a patient suffers from a cancer of the thyroid gland, it's pretty simple to administer to this patient a dose of radioactive iodine, which will be transported by the body into its thyroid gland, will irradiate the gland and the tumor, hopefully curing the cancer. You see immediately that the specification for a diagnostic isotope and a therapy isotopes are completely different. The diagnostic isotope must produce a radiation energetic enough to come out of the patient's body and be detected by the camera. So the best radioisotope for single photon emission tomography SPECT have an energy between 100 and 300 kiloelectron volts, and if you look PET, the annihilation of a positron produces 2 photons with an energy of 511 keV. So on the other hand, also, radiodiagnostic isotopes should have a short half-life to minimize the dose given to the patient. Now, on the contrary, if you send an isotope to destroy a tumor or metastasis, you want the dose of radiation to be confined to the target, the tumor or the metastasis. So you will select an isotope emitting a radiation with a very low penetration to have a very local effect. Ideally, the range of the radiation therapy isotope should be less than 1 millimeter. This is obtained for isotopes that decay by emitting alpha particles or electron. Alpha particles just travel a few micrometers in the body. Electron travel a few hundred micrometers, but less than 1 millimeter. For instance, the isotope iodine-131, which is used for therapy of thyroid gland, decays by emitting photons that have a range of less than 1 millimeter. You also want to inject the patient, unlike the diagnosis, with a large dose, enough to kill the tumor. And you probably also want a longer half-life of your isotope so that the isotope has the time to kill the tumor. The normal way to use therapeutic radioisotope is to attach this therapeutic radioisotope to a pharmaceutical molecule that would search and bind to the tumor or the metastasis. That's all the base of the field of radioimmunotherapy. Today, the most promising therapeutic radioisotopes are, besides iodine-131 that I just mentioned with a half-life of 8 days, there is lutetium-177, 6.6 days, astatine-211, which is an alpha emitter, only 7 hours of half-life, copper-67, 62 hours, actinium-225, 9 days, so 9.9 days, 10 days. Therapeutic isotope emitting electrons can be produced as fission products in nuclear reactors or via PXN reaction with higher energy cyclotron. And for instance, the company of Mr. Baranov just equipped itself with a powerful higher energy 70 MeV cyclotron that will be able to produce a large number of radioisotopes, not only diagnostic, but also for therapy. It's a bit more difficult to produce the alpha-emitting radioisotope. There are basically a number of sources for that. You can use really separation of the stockpile of nuclear waste coming from the nuclear reactors. You can use cyclotron producing alpha beam. And you can use, and that's relatively recent, high energy, very high power electron beam using then gamma N reactions. But using therapeutic radiopharmaceutical only remains a bit of a gamble. Why? As those radioisotopes cannot be detected outside the body, there is no way to check if they are concentrated in the expected target. A significant progress has been made recently when it was found that in some cases, 2 radioisotopes of the same element could be produced, one with a good quality as a diagnostic isotope and the other one with a good quality as a therapeutic isotope. A nice example of those pairs of radioisotopes is the couple of copper-64 and copper-67. Copper-64, which has a half-life of 13 hours, emit high-energy photons and is a very good diagnostic isotope that can be produced on 18 MeV PET cyclotron, while copper-67, which has a half-life of 62 hours and decay by producing very local electron, is a very good therapeutic isotope and can be produced on a 70 MeV cyclotron. So using such pair, you can inject first your pharmaceutical labeled with the diagnostic isotope. You can look where the activity builds up in the body and see if it corresponds to your intended target. And then, if that is satisfying, in a second step, you inject again the molecule with the therapeutic radioisotope. So I think that the motto of the doctor using radioisotope pair could be, I see what I treat, and I treat what I see. Thank you for your attention.
Спасибо большое. Thank you very much, Jan. Мне кажется, что
Thank you very much, Jan. It seems to me that Diagnostics. Thank you very much, Jan. I think that Diagnostics is a very important ability, and being able to select these pairs is an crucially important thing. But I would like to underscore that this is currently an academic objective that both the physicians and the physicists are facing together, because the physicians need to understand the metabolism of this or that body, like with the iodine. No matter what you do, you know it quite well. When you've got certain problems at the nuclear stations, everybody is being iodine. This is the substance, so that you kill it, not the prostate, I mean the thyroid line, yes, to be working perfectly. In this way, it won't start accumulating radioactive iodine. A very trivial, simple thing. That's the example for you how one should choose these pairs. For every organ in the body which is of an interest from the diagnostic point of view, you should select a pair. But for that purpose, you should understand its metabolism. Like glucose, thorium glucose was good for the heart muscle. You need to go for the metabolism which is very selective, very discrete, like in the case of the thyroid line. So that this very same isotope like to be a treatment as well. So this constitutes a very important academic objective, and so as not to repeat and do the same thing again, but go into the future disruptively. That's what we're actively busy with. But again, this is an academic objective for a converging approach between the physicists and the physicians. I used to say that Jongen primarily is specializing in proton treatment, and they have great installations delivered throughout the whole world. But the separate issue is the ion therapy, because on many of its characteristics, it is a very important thing, because we're talking about the resistivity of many diseases to protons. And so ion-based treatment is much more variable and much more efficacious today. But it has a whole number of problems, and we started discussing it. And I would ask Professor Turin, who for many years have been heading our leading institution, the physics of the high energies, where we had accelerator built there when there was no CERN yet, because it has unique opportunities for the AO proton accelerator 70, specifically for the ion-based treatment. Yes, please, go ahead. The ion-based treatment had already been mentioned, because this is an extremely vital, and in a certain sense, this is a new task. For example, whereas in the world we have a little bit more than 80 proton centers, ion centers, there are only 13 of them, and half of them, as it turned out, 7 of them are in Japan. Quite effective irradiation. Why? If protons and ions enable and to release the whole energy within a certain length or within a certain previously identified location, ions additionally impact, and I would give you the same example, like a heavy artillery shell. They break through the both spirals of the DNA, and the possibility of self-recovery is undermined very seriously. It's like a bomb with a uranium core. Yes, yes. Maybe not a very happy comparison. The acceleration Kurchatov Center at the Protvino location possesses 4 machines, and one of them, the so-called booster, today accelerates ions, carbon ions, within the proper interval of energy, because it has to be changed in order to fit into the respective point in between 200 to 450 MV. And this ray comes out with the characteristics which are found satisfactory by the physicians. And we work together with the Obninsk Clinical Center, named after Tsib. We work on the radiobiology, and in this sense, we are studying the effects of ions upon living organisms, in the meantime using animals. But we do note a very notable progress. And so, with this in mind, Radiology Center and the Kurchatov Institute do come out together with an initiative to establish, upon this already existing accelerating center, upon its existing infrastructure, to establish an experimental research center, not only for the research, but also to involve patients in order to study, to continue to study the opportunities that we get from the ion clusters, so as to develop respective protocols and expertise. So this is the so-called first phase, which I hope will be included into the program of mega science program that Mikhail Valentinovich originally was talking about. By applying the competences that one has at the Protvino site, we started developing synchrotron, a special synchrotron for the ion-based therapy, and we very much hope that this also will be supported. So this kind of a joint work together with the healthcare professionals not only inspires us, but most probably gives us the proper understanding of the kind of the future that we should go into. And I should say that the availability of the carbon ion beams that I mentioned at Protvino, at least it's the next 4 or 5 years that you will never be able to find such beams anywhere else in this country, while the domestic installation that we're designing right now will definitely be put to good use, I'm sure. Thank you. Thank you very much. You know, I would draw your attention, since we have dived into such things. You see, in fact, what is how should I put it, nuclear medicine from the point of view of the irradiation treatment? You take a particle, and with this particle you raise something that you want to get rid of, or achieve a certain genetic mutagenesis. And understanding protons, they're very simple, and so proton therapy became a very simple and routine one. There are several companies in the market which produce turnkey the proton centers, and IBA is one of them, for example. However, the fact of the matter is, in as far as the ion therapy is concerned, this really has a lot of future. Yes, indeed, but just 13 centers in the world where, on a research basis, like at the Kurchatov site, such research is being practically done. Ion therapy, on the one hand, is more effective, but on the other hand, is much more complex and difficult in terms of creating the beams and their practical application on the one hand, and the consequences, because irradiation with ions, you produce a lot of fragmentations which in themselves do constitute a lot of danger for a patient and do act as secondary radiation, which can bring about something you don't know. So this is a complexity. And in this sense, in the market, the cyclotrons are being promoted. This is an option of accelerator which is being used for the protons, so as to be able to use it for the ions, and synchrotrons, where in all the centers currently research is being done in ion therapy. So comparing the capacity of a basic, how shall I say it, cyclotron on the basis of the ion therapy of the synchrotron, which is not accelerator, is very important, because we have already conducted one workshop. We have signed an agreement with the Dubna Research Center. We have created a very powerful professional base upon which we will be screening and selecting, so as to understand where we should go, because it's very fine, a very subtle thing. But without doubt, we've got an excellent base at FMBA, which is the Federal Medical Biological Agency, as well as the Russian Nuclear Agency. They've got a company, Rosatom Kloskera, yeah, that's the name of it. So I do think that we've got a great base, a good mutual understanding, and we have a partnership with other companies under the aegis of under the auspices of the Ministry of Trade and Industry. We'll be able to really do it all. But I would like to draw your attention, and I would like to underscore that this is very important, because this is always the nuclear technology, very important for us to be able to understand this is also our research, like, selecting pairs for diagnostics. medics, as well as selecting the safe modes. For example, doctors themselves won't be able to. You see, so right now they can apply. We can explain to them, and so this is resistive tumors for the protons. Let's apply iron ones, and those that would kill these patients immediately. So we'll need to understand the extent to how subtle is this threshold, and how important this deep convergence between the physicians, the medics, and the physicists. In this, only together, we will be able to achieve very quick and very thorough and proper results. Now I would like to give the floor to Sergei Nodov, who is the president of the MedInvest Group. Please. Thank you. Thank you very much. Considering the timing, I'm going to be very brief then. Basically, this challenge, together with the preservation of the nations, is something that we took on a year and a half ago, and the results that we have been able to demonstrate in the area of healthcare and as applied to the subject matter of our workshop in the area of nuclear medicine enabled us to only this year to provide about 50% of the services on the basis of the positron emission tomography. Today we have 14 nuclear medicine centers which are spread throughout the whole of Russia, and 3 cyclotrons in the chemical complex. In the first half of this year we are going to commission into operation. We are currently going through the stage of receiving the certification additional 18 centers of nuclear medicine. In the second half it would be 11 additional nuclear medicine centers. In our plans until the end of the 2021 we are commissioning into operation 51 center of nuclear medicine in the territory of Russia, and so we are going through various stages of construction. Additional 4 centers of nuclear medicine in Kazakhstan, and we have signed with Nursultan Abishevich, the former president, in his tenure, an agreement, and we are actively moving towards competing against the Turks in Shymkent, in Almaty, in Karaganda, and in Astana. These are the names of the cities. And so, principally speaking, if we are to talk about our function, we effectively are applying the very best things that the physics produced. Why am I sounding so confident? Because I fully support what you are saying, that the basic thing here is physics, because I graduated from the physics and mathematics school at the Novosibirsk State University. This was very accidental. It doesn't have any direct linkage. But I can confidently state that as of today, healthcare and medicine is a statistical kind of a science which applies the best practices that we get from biochemistry, from mathematics, and respectively from the physics in our case. Academician Piratov doesn't share your view. Oh, yes, oh, yes. So what are our objectives that we see in development? Extremely important is our collaboration with the healthcare professional. In order for the healthcare professionals to be accepting this technology, we spent about 1 year to promote, in full sense of it, to promote and propagate this new methodology. We did it with all of the representatives, with the General Electrics and Siemens and other companies involved in this process. And today they are producing stunning results, because the demand on the side of the healthcare professionals, year-on-year growth is about 45–50% incremental one in terms of the kinds of the medical aid. This is the first and second thing. In the regions which, thanks to Rosnano, and Rosnano was at the roots of the development of this project in the first stage of it, which is the Sverdlovsk region, Bashkortostan Republic. Today, the area of diagnostics of the oncological disease is extremely high in these 2 locations. So effectively, the kind of the task that we took on together with Rosnano 4 years ago, we picked it up about a year and a half ago. Today gives us effectively the kind of an ability to state what we heard 2 years ago and yesterday, aimed at preserving the nation, because the faster we are diagnosing, the faster we get the opportunity to preserve the number of people who are living in the Russian Federation today. And so, as far as this is concerned, the task that we will set ourselves to deal together is professional training. Why? Because professional training, we will create infrastructure, we will install machines, but unfortunately we won't be able to use these concrete walls if we won't have people inside them, the people who are professionals. Today we have opened several departments at various high educational institutions where we provide original training, following which we offer mentorship and internships at our key facilities. Our company has funded more than 10 million worth of US dollars this year in order to provide for the transit of the best practices from Europe, and on a free basis we will send the government doctors and private clinic doctors overseas in order to be able to bring back the best things in cardiology and neurology, and Sergei Petrovich is actively working with us in this, so as to gain the kind of an opportunity which would indeed be able for us to extend the life expectancy of our nation. And the reason that I'm so inspired about it, because we came from the pharmaceuticals, we're one of the biggest producers of the medical devices and the pharmaceutical products in the territory of the Eastern Europe, and we see the way the market pharmaceutically is contracting because the population is diminishing. So if we get an opportunity to support the government in this endeavor at the stage of the treatment, we decided to go into it in order to create this prevention approach. I'm very much supporting it because, first of all, we're creating a distributed network, and your job is to further create these bigger distributed networks that we should refer patients to, because once you identify a problem, the next thing is you need to decide where it is going to be treated. So very important to have collaboration between the government, between the business, and between the academia, because without the best practices, without the academia, we won't be able to improve ourselves further. And here, I'm very grateful that private business is currently being invited to attend such panels, because NONECO and our company are demonstrating active involvement in the support of the national projects on the part of the mature, very patriotic business. Thank you very much for that. Yes, thank you very much. Thank you, indeed. Concluding this panel, we started talking about individual businesses, and I would like to ask Alexander Hasin, who represents the Center for the Development of the Nuclear Medicine, to say a few words in conclusion. Dear Halkenich, dear colleagues, thank you very much for the opportunity to say a word. Now, bearing in mind the fact that the timing is almost completed, can you hear me? Yes. Bearing in mind the fact that there's no time left, I'm going to be very brief and say that the Center for the Development of the Nuclear Medicine specifically is currently working on a project to organize the production of the strontium generators and other therapeutical isotope generators that have been previously mentioned. And effectively, in about 2 years' time, the issue of cardiology and providing the healthcare system with nuclear technologies in cardiology will be completely resolved. And so in this sense, it's a great pleasure, and it's very important for me to hear that this problem is currently being debated, because the whole market is necessary to be prepared and to be trained in as far as the physicians are concerned. The second point that was raised here, and a very important one, I would like to underscore it yet again. SREM was created as a joint venture between the Kurchatov Institute and private investors, and the cyclotron producer is a BA company. However, cyclotron in itself is not producing isotopes. This is a very complex technology which needs to be introduced, which needs to be developed and perfected, and without the possibility to implement such a project on the basis of a Kurchatov Research Center, this project would have been impossible, because the kind of technical objectives that one needs to resolve in the course of the project without having access to experts, to physicists who not only can do the design and calculate and do other technological solutions, the project would have been impossible. And so in this sense, when we talk about giving the opportunity in healthcare as far as the nuclear medicine is concerned, it is very important to maintain connection with the nuclear centers. Thank you very much. Yeah, well, you see, we've been able to fit ourselves into the timing. I would like to thank all those present and all those who have come to talk to us, and the experts and our panelists, and those who wanted but didn't get the time to speak, to thank you for your participation. And I would like to say that we have done the very right thing, because at the Kurchatov Center we are having a standing meeting whereby we discuss these very vital issues. So there will be a program published soon, and I would like to draw your attention that in accordance with the presidential decree, the Kurchatov Center was assigned by the presidential decree as the lead organization in 2 big major programs. First, national project in genetics, and the second program was mega sciences, which is to create unique mega installations. And so Kurchatov Institution is playing the key role, and apart from it, it is also a key performer. And so in this sense, if we are talking about the individualized healthcare and the adaptation of unique installations in order to solve the purposes of the individualized healthcare, genetics is the very important base. So Kurchatov is where this single place where you can combine these things. So we invite everybody to cooperate. We're fully open, because right now we are also building an educational clinical treatment center. So nuclear medicine definitely, as was from the very beginning, we will make it into the best in the world. Together with the private business, we'll be able to do that with the support from the government. Yes. Thank you very much. Thank you.